So next we're going to extend this idea of finding a path from V1 to V2 to the idea of finding a shortest path from V1 to all other nodes. And one of the reasons we want to do that is to identify central nodes in a social network. Nodes that are likely to have a lot of influence, are well placed, are very well connected. And so we're going to look now at the question of, given a node V1, how central is it? Now, it turns out there's lots of different ways that you can define what central means. We're going to right now focus on a particular one, which is the average shortest path length to all the other nodes. So to find this quantity, we're going to need to calculate the shortest path length from V1 to all the other nodes. Now, based on the analyses we've done so far, finding the shortest path length from some node V1 to some other specific node V2 takes time big theta of n plus m, the nodes plus edges. So following sort of a naive kind of algorithm design, well, this should work, and it's not so terrible, is to say, well, if we want to know the shortest distance from V1 to each of the other nodes in the graph, we can just repeat this process once for each possible target node. So we find the shortest path from V1 to V2, and from V1 to V3, and V1 to V4, and V1 to V5. And we can get all those distances and then say average them to get this measure of centrality. The running time for that approach is going to be big theta of n, the number of nodes, times the time that it takes to do a shortest path search. So it's really n times n plus m, which is n squared nm. Now, the superhero data that we're looking at the moment has on the order of 6,000 superhero nodes. And 6,000 squared is, a substantial number, and it'd be nice to avoid this if we could. So here's some choices for you. One possibility is you can't. Just deal with it. This is the fastest way to do it, which is essentially to repeat individual pairwise searches until you've exhausted all the nodes. Another possibility is, well, you can make it faster by just using a smaller graph. Another choice would be, well, you're searching for V1. We're not sure what to search for. Just search for something that's not anywhere in the graph. And last choice is, actually, you can speed things up by doing the search backwards.